In task and utilities, under task, under linear models, double click on linear regression again. We will still be using HEART-2 dataset over here. And let's choose systolic blood pressure as our dependent variable, our response variable again, our outcome of interest. And let our classification variable, which will be the categorical variables, be number one, sex. We want to adjust for sex, male and female, and also for the cholesterol status. So press and hold control button and then click on cholesterol status. And in the continuous variable, we will have BMI as our exposure of interest, or the predictor, or the independent variable, whatever you want to call it. Now move on to the model tab, click on edit button, control A to select all of them, add them to the model. Okay, options tab, changing maximum number of plot points to no limit, and then submit the code. Okay, so here are our results. We can just read it right here, but it's easier to just let ChatGPT break them down for us. It's much easier to interpret all these results, or just read ChatGPT's interpretations, because they will be much more easier for us. So I'm just going to paste all the results here and submit the results, and let the ChatGPT do the hard work. Okay, so total number of observations 5047. R square has slightly risen. It was 13% with BMI alone, and with two additional covariates now it is 15%, meaning that these three variables together contribute to 15% of the variation to systolic blood pressure. Adjusted R square is 15, very close to our original 15%. So that is good. And then we see that ANOVA F test is less than 0.05, which means that our whole model is statistically significant, meaning that these three variables have statistically significant impact on systolic blood pressure. Moving on, intercept, the non-clinical kind of theoretical value, 91.27 millimeters of mercury. Okay, so here are the important values. Now we see that after adjusting for sex and cholesterol status, the BMI impact on systolic blood pressure has slightly gone down. It was 2 previously, and now it is 1.93, meaning that with each unit increase in BMI, the systolic blood pressure increases by 2 millimeters of mercury. Pretty significant or strong predictor of systolic blood pressure. Moving on to sex, female versus a male. We see that after adjusting for BMI and cholesterol status, female in fact have slightly higher, I mean it's not very significant, but still it is reversing our finding which we had previously, that female has lower systolic blood pressure compared to males. But it appears that the cholesterol status and BMI has something to do with the male having higher systolic blood pressure. And after we adjusted for these two factors, we see that females in fact have slightly higher, tiny bit higher than males. Okay, but overall we can say that suggests that no meaningful difference between male and female in systolic blood pressure exists. Moving on to the cholesterol status, we see that the reference assigned by SAS was high cholesterol status, and compared to high, the people with borderline cholesterol status has 4.88, almost 5 millimeters of systolic blood pressure lower, right? So borderline cholesterol is associated with 5 millimeters of mercury lower systolic blood pressure than high cholesterol. Okay, that also makes 100% sense. And those with desirable cholesterol status has in fact much lower systolic blood pressure per unit. So, sorry, not per unit. This is compared to those who have high cholesterol. So they have almost 8.4 millimeters of mercury lower than those who have high cholesterol. Okay, and both the differences are statistically significant because they are lower than 0.05. Okay, so here is the practical interpretation. A patient with BMI 30, male, high cholesterol would have a predicted systolic blood pressure of which is predicted by this equation 1.93, that is the slope for BMI, times 30, which is the BMI for this subject, and equal to 149.2 millimeters of mercury. Okay, let's look at some of the visuals here. Okay, this visual we have already analyzed. And again, QQ plot is important here. We see that the residuals are deviating from the normal distribution at both lower and upper end, specifically at the upper end. The people with higher systolic blood pressure, they are not normally distributed, but overall we are fine with the results we have received. See you in the next video.